Hi everyone, my name is Ksenia and I've been studying chemistry for over 15 years. On this channel, I'm explaining the most important chemical topics briefly in simple terms. In this video, I will talk about ionization energy and how it changes across the periodic table. Ionization energy – it's amount of energy needed to remove an electron from an atom or an ion in its gas form. It measures how tightly an electron is held by an atom. Let's imagine a neutral atom like a carbon. Removing the first electron from this atom requires less energy than removing the second electron, and so on. This happens because when the first electron is lost, the atom becomes positively charged and the remaining electrons are pulled closer to the nucleus, making them harder to remove. Ionization energy depends on the atom's radius, electron configuration, and nucleus charge. And now I will explain with a few examples and talk about how ionization energy changes across the periodic table. Let's start with elements from the same period. Moving from left to right, the size of the atom decreases, and the larger the radius, the less energy is needed to remove an electron from the outermost electron shell. Because in this way, the electrons are less attracted to the nucleus. Also, moving left to right, the nucleus charge increases, which means electrons are strongly attracted to the nucleus, making them harder to remove. Take, for example, lithium and nitrogen. Lithium has a smaller radius and a smaller nuclear charge, so it's much easier to remove an electron from its atom compared to nitrogen. Generally, as we move left to right across a period, ionization energy increases. But there are some exceptions to this trend of increasing ionization energy within a period. Let's take, for example, beryllium to boron and nitrogen to oxygen. Boron's electron configuration makes it easier to remove an electron compared to beryllium, and oxygen's configuration makes it easier to remove an electron compared to nitrogen. Let's look what happened with elements in the same group. As we move down, the atomic radius increases, making it easier for the outermost electron breaking away from the atom. In other words, as we go down, ionization energy decreases. Let's take magnesium and barium as example. They are in the same group and each with the 2 electrons in the outer level. However, barium has a larger radius, so its valence electrons are less attracted to the nucleus. Although the charge of barium's nucleus is also greater than that of magnesium, its positive charge is shielded by layers of the electrons. Therefore, it's still easier to remove the outer electron from a barium atom than from a magnesium atom. In summary, ionization energy – it's energy needed to remove an electron from an atom. The first ionization energy is less than the second ionization energy, and so on. Within a group, ionization energy decreases as we move down, but within a period, it generally increases from left to right. But you should remember that there are exceptions to that trend. That's it for today. If you found this video helpful, please like it and subscribe to my channel. And see you next time!